Welcome to another lesson. In today's lesson, we'll be learning about a very interesting concept, which is Coulomb's law. Now, if you're preparing for a physics examination, whether in grade 11 or 12, or an entry-level student at the university level, of course, now this is a concept that you should be familiar with. And also, if you're an engineering student, this is something you need to brush up on because you might be needing this concept within your career as well. Now, Coulomb's law refers to the forces of attraction between two charges. And this is what we're going to be learning in today's lesson. We're going to be able to calculate how to find out the force which is existing between two types of charges, whether a positive charge or a negative charge, based on a certain distance between them. So let's get right to the lesson.
So in this lesson we're going to be learning about Coulomb's law, which simply states that if we have two charges located at a certain distance with respect to each other, these charges are going to exert a force onto each other. And this is mainly represented by the formula which states that the force these charges exhibit into each other equals to K, which is a constant that we're going to be elaborating on right now, multiplied by the first charge, let's say charge A, charge B, over the distance between them squared. This is representing the Coulomb's law, which indicates if we have two charges, let's say I have a positive charge and I have a negative charge, and they are located at a distance r with respect to each other. Now, if I call the blue charge A and the red charge B, if I'm going to consider A by itself and I'm going to examine the forces acting on A, let's represent A as a dot, as a point. So what are the forces acting on A? Since A is positive and B is negative, it means they are going to be attracting each other. So because we're considering A, so the force of attraction will be exerted from B on A. So the force of attraction will be this way. The force of B on A. And if I'm going to consider object B, the force of attraction will be the other way around. It's going to be F of A on B. So you notice if we have two charges in this case, whether they are positive, negative, similar charges, opposite charges, if we place them at a certain distance with respect to each other, these forces are going to exhibit a force of attraction or repulsion. And based on Coulomb's law, there's the law of attraction or repulsion, which states that charges that are similar, let's write down this law because it's quite important and you should be knowing this or learning about this. The law of attraction and repulsion. Which states that opposite charges attract and similar charges repel each other. So if we're going to have, let's say, two charges which are positive, let's call this one A and this one B, and we're going to consider the charge A. So B will be pushing it to the left. It will be the force of B on A. And A will be pushing B to the right. It's going to be the force of A on B. And it's similar to negative charges as well. However, if we have opposite charges, as we have mentioned earlier, let's call this charge B and this charge A. We're going to have a force which is the force of, if we're going to consider A by itself, it will be the force of B on A. It's an attractive force. And if we're going to consider B, it will be the force of A on B. As you can see, they're quite opposite to each other compared to similar charges. So this is mainly the law of attraction and repulsion that you should keep in mind. It's like a side note based on Coulomb's law. Now let's get back to Coulomb's law and dissect the law with further details. We're going to elaborate on Coulomb's law right now and what are the variables within the formula. So if we're going to take a look at Coulomb's law, the formula is F equals to K, the charge of A, multiplied by the charge of B over the distance between those charges squared. So if you have charge A, charge B, and there's a certain distance between them R, the unit of measurement for charge A, let's say QA, it will be measured in coulombs and we give it the letter C. And for B, the charge will be QB and the unit of measurement will be coulombs as well. And the distance will be in meters. So let's add all these details to the formula in front of us. The force represented by F, which is going to be measured in newtons. K is a constant, which is based on the experimentation that Coulomb did in the first place to come up with this law. Keeping in mind that this law applies mainly to spherical charges or point charges. So if you have a square object, rectangular object, the results will be quite off. This value, you should memorize this value. It's 9 multiplied by 10 to the power of 9 in Newton meter square per Coulomb square. Now this is a value that you should memorize, like you can think about it as in the same sense as Avogadro's number or the gravity, which is 9.81. So this is a constant that you're going to be using in order to make sure that your formula works in that sense. So a QA, it will be the charge of A, which is in coulombs given the letter C, and QB, it's the charge of B given the letter C as well, the unit of measurement is coulombs. R square, which is for the distance between the charges, distance between the charges measured in meters given by the letter M. So what do we have here? Let's recap it quickly. We have the force in newtons, the force between those charges. So if I'm taking a look at my charge A, what are the forces acting on it? Charge B, what are the forces acting on it? So I'm going to calculate this force. The first thing I need to know is the constant that I have. I should memorize this, which is 9 multiplied by 10 to the power of 9. I do have the charge of A measured in coulombs, given the letter C. The unit of measurement is coulombs, QB. And the distance between these charges, which is basically R, and we square the distance. So this is mainly about Coulomb's law. So let's put this law to the practice. Let's have a small example on Coulomb's law. Let's say I have a charge A and a charge B, and the charge for A, it is -6 multiplied by 10 to the power of -6 coulombs. And the charge of B, it is 3 multiplied by 10 to the power of -6 coulombs, and they are placed at 0.2 meters with respect to each other. So what we are going to be doing in this case, we're going to go ahead and apply the formula as is. The force of, now the question should be very specific. Are you considering the forces acting on A or on B? Let's say I want to have the force acting on A to be calculated. So the charge that I have, which is A, the force is acting on it. It's an attractive force from B. So I'm going to experience a force from B, F of B on A. Now, if I'm considering B, the case will be different, will be reversed. It will be F of B on A. So because the question said, let's consider this charge, so I'm going to calculate the force acting on this charge. In this case, it's going to be F of B on A equals to K, which is 9 multiplied by 10 to the power of 9. I just simply put the formula first, just to keep things quite organized. QA into QB over the distance between them squared. Now, let's put in the numbers. I have 9 multiplied by 10 to the power of minus 9. The charge of A, we're not going to be putting any signs because the formula just simply gives me the magnitude. And we are able to indicate the direction of the force based on your analogy, whether they are attracting or repelling each other. So we're going to drop the minus sign, just simply keep it as a number. 6 multiplied by 10 to the power of minus 6, multiplied by 3, multiplied by 10 to the power of minus 6, over the distance between them, 0.2 squared. So you're going to just simply crunch in these numbers on the calculator, and this value will be representing newtons, which is the force of, in this case, attraction, the force of B on A. So this is a basic example just to help you understand the concept of Coulomb's law. Just simply crunch in these numbers on the calculator to get the exact value. But in terms of the application, it's very straightforward. We have the value of K, we have QA, QB, both of them, they are given to us. And the distance between them is also given to us. It's simply a matter of plugging into the equation. So to have a quick recap on Coulomb's law indicates that if I have two charges, whether they are similar to each other or opposite to each other, these charges, if they are placed at a certain distance, they're going to exhibit a force onto each other. So if I take one of those charges and I'm going to consider the forces acting on it, let's say, I'm able to calculate it using the following formula, which states that the force that you have equals to this constant K, which is 9 multiplied by 10 to the power of 9, multiplied by the first charge, multiplied by the second charge, divided by the distance between those charges squared, and you're able to get the force in newtons. So this mainly wraps it up for Coulomb's law in a simplistic manner. What we're going to be doing in the next video, I'll be sharing with you a practice problem where we are able to have a combination of let's say Pythagoras theorem along with the Coulomb's law, where we're going to be placing the charges beyond one dimension. We're going to have them placed at 2 dimensions, and we're going to apply the Coulomb's law and calculate the net force acting on these charges.
I truly hope that you found the lesson beneficial. If you did, make sure that you join and subscribe to our community just to make sure that you stay tuned with all of these latest updates, whether we're talking about physics, mathematics, engineering, personal finance. These are quite solid educational stuff that you should be familiar with. So if that's of interest to you, would love to see you part of our growing community, and I'll see you in the next class.